Water and food systems. An interstellar mission would require tons of drinking water, food, the equipment, space, materials, and supplies to store, preserve, use, and recycle their waste. And the bulk and mass that these resources will require would be gargantuan, not only because of the large size of the crew of an interstellar mission, but also because of the long flight ahead of them. Not only these, but the crew will likely have offspring, the next generation, who will also require nurture from water and food. And gathering water and food from destinations en route is hardly feasible and would only further complicate and lengthen the mission by unacceptable margins. Our technical ability at extracting water from space destinations is precisely null. And our skills at producing food away from Earth are at best in their primitive stages. So the problems presented by our need for water and food in space are tremendous, to put it mildly. It is estimated that the water required for a 40-year space voyage for a crew of 6 would be from 44 to 175 metric tons, depending on a 90% recycling efficiency and on water use restrictions from limited to moderate. 40 years, of course, is likely not enough time to complete a voyage to Alpha Centauri with current propulsion. So the water mass required in reality would be many times this amount. But even considering this amount, up to 175 metric tons, brings swift doubts to any plans for interstellar travel. Recall that our best and largest rockets can't lift more than around 50 metric tons of total payload. So the figures bring hopelessness when we consider the true requirement for water alone for a small crew on a deep space mission. If we were able to mine water from the moon or other solar system bodies, the task of lifting it from Earth would be alleviated, but the mission would become magnitudes more costly and complicated. And time would be added to the voyage. A lot more time. Also, it must be considered that water requires bulky and heavy storage tanks and complex and bulky systems to harness it, treat it, recycle it, and dispense it. Water in space also needs to remain warm so it can stay liquid. And space is bone-chilling cold. Heating water is energy-intensive, and energy is an expensive resource away from our or any other sun. Although water may double as a radiation shield, it must be pumped and kept stored around the living areas of the crew, a complex and resource-intensive task. For this, containers need to remain watertight and heated at all times, consuming resources and energy every hour of the mission. Sadly, we utterly lack the propulsion and payload capacity to get the amount of water needed to space. And we lack the advanced storage systems to store the water, even if we got it to space. And although we have some experience recycling water, our recycling efficiency is not enough to limit the water amount needed for long voyages. Lastly, we lack the technology and experience in harnessing water from space or other heavenly bodies. It is estimated that a round trip to Alpha Centauri, for a crew of 6, at 10% of the speed of light, the crew would require at least 330 metric tons of food. That is without including the systems and equipment to maintain such food or safety margins. Obviously, lifting this amount of food to low Earth orbit is a daunting challenge, using current technology. Imagine the challenge of transporting this mass to another star system and preserving much of it throughout the voyage. Even if somehow we figured out how to farm and grow food en route, this would take a ridiculous amount of space, resources, and additional special equipment. And all Earth-based food requires solar energy, something that will be extremely limited during most of the trip. Also, food growing and farming requires gravity, a challenge yet to be solved. First, the time required to travel to Alpha Centauri makes it prohibitive to even plan on the food required for the trip. As of now, it can take from hundreds to thousands of years to complete the voyage. So, obviously, we simply cannot plan on taking all of the food needed. Instead, we would need the technology, environment, and skill to grow, harvest, and consume our food en route. Gravity should be a solved problem. Simply put, all that grows on Earth needs Earth gravity, and trying to go around this requirement is simply dangerous. Also, solar radiation is necessary. We need to provide this radiation from our sun or another star somehow, or closely duplicate it. For this, vast arrays of advanced radiating sources need to be in place, and a room with a few lights just won't do it. And contrary to depictions in sci-fi media, a room with a few pots with plants and some cages with some farm animals just won't work. The ship or ark would require vast open areas for fields of food, much like those on Earth. and gigantic farms for all types of animals to grow. Sadly, eating crickets and rabbits for meat for over 100 years of travel will get very aggravating and demoralizing for the crew. And a limited variety of fruits and vegetables will do the same. The crew, even a small crew of 6, needs a wide variety of Earth-like foods. I believe the difference between Earth and space-grown food cannot be detectable for such a long period of voyage to succeed. Food farming and growing are still in their infancy, and although some foods have been grown in space, their taste and consistency just isn't the same. And large-scale food growing has not occurred in space. Ultimately, we must admit our delayed state of advancement in the area of water harnessing, storage, and use in space, as we must recognize our infant state of food growing, storage, and use in long-duration space habitation. We must solve problems of gravity and radiation and be able to lift more mass and build larger ships. Until then, any talk on interstellar travel is just hypothetical and wishful.
Thank you for listening to this podcast or watching this video. Please subscribe, like, and share so you can support this work and so I can reach more people like you. If you'd like to support this content further, please click on the links provided here. Thank you again. Have a great day.